we are going to discuss about the second classes about the real numbers. We have discussed natural numbers and also last we have discussed about even number of prime numbers. Let us number and composite numbers. So this I will say that you must, we will discuss about the composite numbers and prime numbers. In last class I have discussed that prime numbers. What is prime numbers? Each number, its factor, it has two factors, one and that is called your prime number. Suppose 2 equals to 1 into 2, 5 equals to 5 into 2 also. Another type of factorization which will be for the number 4. 4 is the composite number. If we factorize, it is called, this is the prime factorization. When number can prime numbers, the system of prime numbers up to infinitive, uncountable, up to 100. There are 25 prime numbers. And others, when we go to research other classes, there are so many prime numbers are there. There is a discussion about it. I will say one minute. So the prime number systems, the limitation, the number of prime numbers, prime number are unlimited. The prime number, there is collection about me within 1 to 100. Within 1 to 100, there are 25 prime numbers. Between 1 and 100 prime numbers. But between 1 to 1000, there are 168 prime numbers. 1 to 100, 1 to 100. Equals to 25 prime numbers. Prime numbers. 1 to 1000. Between 1 and 1000, there are 168. 168 prime numbers. Between 1000 to 2000, 1000 to 2000, there will be 135. Between 400, between 200, 2000, 3000, 1000 to 2000, 135 prime numbers. Between 2000 to 3000, there are 127 prime numbers. Between 3000 to 4000, there are 120 prime numbers. Between 4000 to 5000, there are 119 prime numbers. So the numbers of numbers in the number systems, in our Indian number systems, in these decimal number systems, the numbers of the prime numbers, the availability of prime numbers are uncountable. We cannot count the prime numbers. So these are the prime numbers. All about prime numbers. When a number will be factorized, maximum factorizations, we can find the factors itself and one, that is called prime number. And the other number other than the prime number are composite numbers. The number has factorized way, that means they have the factors are called composite numbers. But one is a separate number that is neither prime nor composite. Into 1. So it has only 1. It has not any other factor, more than one factor. It has only one factor, single factor. So 1 is a special number. Neither a prime nor composite. So between 1 to 100, there are 25 25 prime numbers. So how many composite numbers are there? There are 74 composite numbers, not 75, because number, special number, that is neither prime nor composite. So availability of prime numbers in the number system is unlimited. This is what is the fundamental theorem of arithmetic? Fundamental theorem of arithmetic: every composite numbers, all composite numbers, every composite numbers can be expressed or can be factorized in the product of prime numbers, that is prime factorizations, and these factorizations is unique apart from the order in which the prime factors occur. That means, what is the fundamental theory of arithmetic? Fundamental theorem of arithmetic. This is the fundamental theorem of arithmetic. That means 4 equals to 1 into 4, 4 equals to 2 into 2. Suppose 6, 2 into 3, 1 into 6. Suppose 8. Every composite numbers can be factorized in a unique way. Unique way can be factorized prime factorizations. That means that is the product of the prime numbers. Factorize themselves as the product of the prime numbers. According to the product of prime numbers, 8 equals to 2 into 2 into, that means this equals to 4 into 2, this equals to 1 into 1, this equals to 2 power cube into 1. In a different way we can factor prime factorizations. Prime factorization means only prime numbers, so the cube of 2. So prime factorization, product of the prime numbers, only product of the prime numbers that can be expressed. That means every can be factorized as the multiple of the prime number, equals to 2 into 5. This is the prime factorizations. 12 equals to 2 into 2 into 3. 15 equals to 2 into 18 equals to 2 into 3 into 3. This is 2 3 is 6, 6 3 is 18. Likewise all composite numbers, each composite numbers can be expressed or can be factorized primely in the unique way. No other numbers except 18 can be factorized as 2 into 3 into 3. This equals to 2 into 3 square. No other number except 18. That means 18 is a unique factorization process, that is 2 into 3 into 3. Unique factorization process. That is the unique factorization process. That is your all about your fundamental theorem of arithmetic. Then another prime factorization. The prime factorization is a natural number is unique except for the order of its factors. Prime factorizations and other numbers, so we can find prime factorizations. Suppose there is a number 36 equals to 2 into 2, 2 to the 4, 4 3 ja 12, 12 3 ja 36. So we can write this equals to 2 square into 3 square. 2 square into 3 square. That is the prime factorizations. Suppose 48. 2 into 2 into 2, 2 to the 4, 4 to the 8, 8 to the 16, 16, 3 ja. This equals to 48, 2 power 1, 2, 3, 4, 2 to the 4 into 3. This is the prime factorizations. Suppose another number 60 equals to 2, 2 ja 4, 4, 3 ja 12, 12, 5 ja 60. 2 square into 3 into 5 and so on. We can factorize. You can factorize every number in the unique way. This is the unique way. You cannot factorize any other number in this way. You cannot factorize any other number in this way. You cannot factorize any other number in this way. So this is the prime factorization process. This is the prime factorizations. We have discussed in the earlier cases how can we find the HCF. HCF in the Euclidean division algorithm. We know that, but according to prime factorizations, using the prime factorization method, we can find also HCF and LCM. We can find the HCF and LCM using the prime factorization method. How can we use this prime factorization method using HCF? Suppose HCF, first is HCF of 6 and 9. Find the HCF of 6 and 9. First, I will discuss the HCF. HCF is the product of the smallest power of each common prime factors in the numbers. Very crucial and very important. We have to keep in notion. We have to keep in in vision that smallest power. That means we have to factorize in the prime equals to 2 into 3. That means this 2 to the power 1 into 3 to the power 1. The power. We have to use the power. Smallest factors also 9. 9 equals to 3 into 3. This equals to power of 3 equals to 2. HCF equals to, what is the HCF? Product of smallest power of each common prime factors. What is the prime factors of 6? 2 and 3. What is the common factors of 9? That is prime factors of 9 equals to 3. Common factors. What is the common factors? Only 3. The smallest power of 3 equals to 3 of 3 power 1. This equals to 3. That means HCF equals to 3. When we can find, write down product of the smallest power of each common prime factor is in the numbers. Product. If in this number, if we find the common number 2, then we can use the common smallest power number of the 2. So we will discuss in another example. LCM. How can I find out the LCM of the two number? LCM is the product of the greatest power of each prime factor involved in the numbers. Greatest power. Suppose 2. First common product of the greatest power of each prime number. Each and every, not common. In the LCMs, that is number given that the product of the greatest power of each factors. The greatest power. Suppose 2. 2 is the prime factors. 2 greatest power is 2 to the power 1 into 3 square. Greatest power is 3 power 2. This equals to 2 into 3 square equals to 9 equals to 18. The LCM equals to 18 into LCM equals to 3. So we can find out in this way. Suppose we have discussed about two numbers 36 and 48. 36 and 48, this equals to 2 to the power 4 into 3 to the power 1. Suppose this is the prime factorization of 36. 2 into 2 to the 4, 4 3 ja 12, 12 3 ja 36. So this is 2, that means 2 square. 3 into 3, 3 square. 2, 2, 2, 2, there are 4 2's are multiplied, then 2 to the power 4, this into 3 to the power 1. So HCF, product of the common lowest power of the common factors. This is the 2 is the common factors, but which is the lowest power? 2 square into 3 also. What is the lowest power? 3 to the power 1. This equals to 4 into 3 equals to 12. So HCF of 36 and 48, this equals to 12. The product of lowest power of common factors, common prime factors. Mind it, that is common prime factors, not only common factors, common prime factors. Product of smallest power of each common prime factors is the in the numbers. So the LCM. But how can you find LCMs? At the highest common factors. Common factor is 2, but the highest power is 4 to the power 4 into the common factor is 3, but highest factor is 2. This equals to 2 to the power 4, 2 to the 4, 4 to the 8, 8 to the 16. 16 into 9, 144, 69 the 144. So this is the HCF, this is the LCM. I think you are confirmed about how can you find out the HCF common factorization method. We'll discuss in exercise 1.2 this type of numbers. So here is some there is some result, that means the result come out from this process. Suppose 6 and 9. 6 and 6 into 9 equals to 54. Multiplication of two number, when we find out the multiplication of two number, assume we have to see that multiplication of 6 and 9, this is 54. We multiply the HCF and LCF. HCF into LCM, this equals to 3 into 18. This equals to 54. That means the product of HCF and LCM equals to the product of given two numbers. This is the very important numbers. That means why important? We'll discuss. Suppose two numbers are given and HCF is given. Find out the LCM. It is not necessary to go through the prime factorization method, go through all the procedure. We do not have to do. Only what happened? We have to LCM. Find the LCM equals to product of two numbers, product of two numbers. The product of two numbers equals to HCF into LCM. Product equals to product of numbers equals to HCF into LCM. Product of two numbers equals to the HCF into LCM. But when anyone two numbers is given or otherwise the numbers are given and then HCF is given. Then find out the LCMs. Suppose there are prime numbers, big prime numbers, so we do not know whether it is prime or not. In that case, find out HCF in the algorithm process. In the Euclid's division algorithm process, we can find the HCF very easily. That is a very easy process. This is the longest process. When the prime factors are very small, we can know easily. But when the prime factors will be very lengthy, more than 4,000, 3,000, 2,000, so then it will be clumsy for us. So using Euclid's division algorithm, we can find the HCF very easily. Suppose 36 and 48. 48 divisible by 36. 36, 1 there 36. 2, 4 minus 3, 1. Another 36. 12, 3 there 36, 0. So HCF equals to 12. HCF equals to 12. We can find the HCF equals to 12. Very easy. HCF equals to 12. This is the Euclid's division algorithm. In this process, is very easy. 48 into 36 by 12 and 3 ja 3 24 to 3 4 ja 12 to 14. So that is your LCM. In this way you can find the same as LCMs. But when its question is particularly question is asked, find out the SCM or LCM using the prime factorization method. So we have to opt this process also. We cannot opt this process. So discuss about the chapter exercise 1.2. This is all fundamentals of this exercise. To express the number prime factors. 140. Exercise 1.2 number 1. 140. The process I will discuss 140. 140 can be divided by 2. So 2 7s are 14, 70. Another also 2 or 2 3 are 6, 10, 2 5 are 10. So when the unit place is odd numbers, then cannot be divided by 2. So we can now 5 7 only 7 is a prime factors, prime number. So 140 equals to 2 into 2 into 5 into 7. This equals to 2 square into 5 into 7. This is the prime factorizations of 140. Another number is 156. 156. This equals to 156. Well, prime number we have to discuss serially prime numbers 2, 3, 4, 2, 3, 5 serially. Divisible 2, 2 7 are 14, 1 16, 2 8 are 16. Another 2, 2 3 are 6, 18, 2 9 are 18. Another 3, 3 1 are 3 3 are 9. This are 156 equals to 2 into 2 into 3 into 13. This equals to 2 square into 3 into 13. This is the prime factorization. Other numbers it starts for you. You can do all the prime factorization in this process. Very easy process. You have to take small prime factors, prime numbers. You can divide division process or long division process. That is the prime factor. You can find the prime factorization process. Number 2. Secondly, number 2 we have to discuss. Number 1, the other numbers third and second, third IB and B. That is homework for you. You can do easily. Find the LCM and SCM of the following pairs of integers and verify the LCM into SCM equal to product of the two numbers 26 and 91. Suppose we take 510 and 92. Second, number 2. Second, find the LCM and SCM of the following pairs of integers and verify the LCM into SCM equals to product of two numbers 510 and 92. Suppose 510 and 92. First we have to find the prime factorizations. 510, 2, 2 2 are 4, 11, 2 5 are 10, 2 5 are 10. Another 5, 5 5 are 25, 5 1 are 7, 7 1 are another 3, 3 1s are 3, 21, 3 7 are. So this 510 equals to 2 into 3 into 5 into 70. All are prime numbers. 92. 92. 2 4 are 8. 2 4 are 8. 12. 2 6 are 12. 2 2 are 2 3 are 23 is prime numbers. So this equals to 2 into 2 into 23, 2 square into 23. HCF. HCF equals to this equals to only 2. 2 to the power 1, 2 to the power 1. This equals to 2. LCM. LCM equals to the highest power of 2 equals to 2 square into highest power of 3, 3 into 5 into 17 into 23. This equals to 1 This equals to 0, 6, 4, 3, 2. 23,460. So this is the LCM. Then question is there, find following and verify that LCM of SCF equals to product of two numbers. LCM and SCF. LCM and LCF. LCM into HCF equals to 23,460 into 2. 2 0 is 0, 2 6 is 12, 1 2 4 is 8, 1 9, 2 3 is 6, 2 2 is 4. The product of two numbers. This equals to 510 into 92. This will be 510, 92. 2 0 is 0, 2 1 is 2, 2 5 is 10, 9 0 is 0, 9 1 is 9, 9 5 is 45. 0, 2, 9, 6, 4 6 9 2 0. 4 6 9 2 0. So the product of LCM into HCF, this equals to product of two numbers. This is verified, thus verified, approved. So in this way you can verify the others two also. There are first 26 and 91, very easy questions, and other is 336 and 54. That is also not too difficult. That also you can perform it. Number 3, find the LCM and LCM of the following numbers, following integers by applying the prime factorization method. When we find the number 3, LCM and LCM more than two numbers in the prime factorization methods, how can we apply? It is also very easy process. Number 3, first find the HCF and LCM of 12, 15, 21. 12, 15 and 21. We have to find out the HCF, LCM of 12, 15 and 21 in the process of prime factorization method. How can we find out the prime factorization method? 12 equals to 2 into 3. This equals to 2 square into 3. This is the prime factorization of 12. 15 equals to 3 into 5. Only 3 into 5. There is no repetition of any numbers. 21 equals to 3 into 7. So HCF equals to very easy. That is 3. 3 power 1, 5. 3 power 1, 3 power 1. This equals to 3. So HCF equals to 3. LCM. First common factors is 3 power into then what is the common, that is common between 2, but there is not any common between, so all numbers will be 2 square into 5 into 7. This equals to 420. You can multiply them. 2 square 4 5 is 20, 23 is 60, 60 into 7 is 420. So this is the HCF and LCM using the prime factorization method. Another number is 17, 23, 29. There are HCFs when no any other number common numbers, then HCF will be 1. Suppose any two number. Suppose second number is 17, 23 and 29. 17, 23 and 29. HCF 17 equals to 1 into 17, 23 equals to 1 into 23. All are prime numbers. 29 equals to 1 into 29. So HCF equals to 1, simply 1. When all are prime numbers or co-prime numbers. Suppose 8 and 9. HCF of 8 and 9. What is the HCF of 8 and 9? 8 equals to 2 cube. 9 equals to 3 square. There is not any common factor. So HCF equals to 1. HCF equals to 1. Here HCF equals to 1. LCM equals to 17 into 23 into 29. 17 into 23 into 29. Whatever may be, you can do yourselves. Here LCM equals to 2 cube into 3 square. Then you can find out the LCM also. This is the process when the numbers are prime numbers or co-prime numbers. What is the difference between prime numbers and co-prime numbers? Prime numbers means all are prime numbers, but co-prime number means these two numbers are not prime numbers, they are composite numbers. But co-prime means they have not any common factors themselves. They are called co-prime numbers. Co-prime numbers means they have not any common factors themselves. Though they have not any common factors, they are called co-prime numbers. So if the two numbers are co-prime, then HCF equals to 1 and LCM equals to product of two numbers. 8 in LCM equals to 8 into 9 also. This equals 72. This is 8 into 9. This equals to also 72. You can find out very easily. Then we go through number 4. Number 4, the question they are given HCF of 306 and 657 equals to 9. Find the LCM of 306 into 306 and 657. HCF of, given that HCF of 306 and 657 equals to 6. Sorry, this equals to 9. HCF equals to 9. LCM equals to product of two numbers 306 into 657 by HCF. HCF equals to 9. We can find LCM in this way very easily. So how can we find out this? 9 1 is 9, 9 7 is 63, 27, 9 3 is 27. 306 into 73. This equals to 306, 73, 3 6 is 18, 1, 3 3 is 9, 8, 3, 1, 2, 2, 2, 3, 3, 8. In this way we can find the LCM. This is the LCM of 306 and 657. Then another number, number 5. What is the number 5? Check whether 6 to the power, number 5. Check whether 6 to the power n can end with the digit 0 for any natural numbers n. Unit number. Suppose check whether 6 to the power n ends with zero digit 0 or not for any natural number n. N is a natural numbers, so 6 to the power n cannot be an integers or cannot be an your rational numbers. That is the natural numbers. 6 to the power n. It can be checked in the two ways. You can check. Suppose 6 to the power 1 equals to 6. 6 to the power 2 equals to 36. 6 to the power 3 equals to 216. 6 to the power 4 equals to 1296. So when we find the powers of 6 and we increase the power of 6, we can find the unit places ends with 6 only. So 6 to the power n also and with 6, whatever may be the n. If n belongs to n belongs to n is a natural number, belongs to n is natural numbers. This is the process. So 6 check whether 6 to n is 0, it cannot be n is 0. So it can ends with 0. This is the first process. Secondly, how can you find out whether the 6 to n is 0? Any number ends with 0. Suppose discuss with 10. 10 equals to 2 into 5. 20 equals to 2 into 2 into 5. This equals to 2 square into 5. 30 equals to 2 into 3 into 5. 40 equals to 2 into 2 into 2 into 5. 50 equals to 2 into 5 into 5. So when the number ends with 0, there will be factor must be 5. Must be 5. Any factor, any one factor must be 5. But when 6 to the power n, you can write any numbers ends with 0 has a factor 5. Most has a factor 5. 6 to the power n equals to 2 into 3 to the power n. This equals to 2 to the power n into 3 to the power n has not any factor 5. So it 6 to the power n can end with 0. You can opt this two process also in this different way. And when we find the factorization your powers of 6 or product of 6, then we can find when the power of 6, then we can find all unit digits always ends in 6. So we cannot find 0, 6 to the power n ends with 0. And otherwise, when a number ends with 0, it must have factor 5. Otherwise, it cannot be ends with 0. So when the factor ends with 5, but here is 6 power n cannot have, and it do not have any factor 5, so it cannot end with 0. This is the number 5, and then number 6. Number 6, what is the question? Explain why 7 into 11 into 13, 7 into 11 into 13 plus 13. Explain and each composite numbers. Explain each composites. This number is composite. How can we explain? This equals to when this number is common. 13 into 7 into 11 into 1 plus 1. 13 will common. This equals to 13 into 77 into 177 plus 1. This equals to 13 into 78. This equals to 2 into 13 into 39. When any number is expressed as 2n, so this is a composite number. So 2 into 13 into 39 is composite. Hence In this way, you can prove that this number is composite. Then another example is there. You can solve this very easily. Then we go through the number 7. First, when we solve the question, we go through the question very thoroughly. Then we can solve the answer very easily. When we do not go through the question, then we cannot answer the questions. There is a circular path, and in the sports field, Sonia takes 18 minutes to drive one round of the field, while Robbie takes 12 minutes for the same. Suppose they both start at the same point of end, the same times, and go to the same directions. After how many minutes they will meet again in the starting point? There is a circular path. Suppose there is a circular path, and this is the starting point. This is the starting point. From the starting points, two persons, Sonia and Robbie. Sonia and Robbie, they started to run in the same directions. Suppose clockwise direction. Suppose they run in the clockwise directions. Sonia takes 18 minutes to complete one round, and Robbie takes 12 minutes to complete one round. The question is there, after how many times? The question is there, and go to the same direction. After how many minutes they will meet again in the starting point? In the starting point, and other points they can meet also. But we do not consider other points. We consider only the starting points. In how many minutes, after how many minutes, that means in the particular which time, how many minutes they meet each other in the starting point. Starting point means when Sonia, consider Sonia, after Sonia, in 18 minutes, this cover one round. Another 18 minutes, 36 minutes, cover second round, 54 minutes, third round, 72 minutes, fourth round. Then Robbie. Consider Robbie, 12 minutes, one round, 24 minutes, second round, 36 minutes, third round, 48 minutes, fourth round. Fifth round, 60 minutes. Either fifth round, 90 minutes. So in so on. Anyway, we can sixth round, 72 minutes. Sixth round, 102 minutes. But firstly, in how many minutes they will meet each other? 36 minutes. You can easily recognize that at 36 minutes they will meet each other. After 36 minutes, Sonia covered 2 rounds, but Robbie covered 3 rounds. Robbie covered 3 rounds, but they will meet at the starting point. And another point also they can meet after 72 minutes. They will again meet each other at 72 minutes. But question is there, after how many minutes they will meet again at the starting point? They will meet firstly at the starting point, that is 36 minutes. After 36 minutes, they will meet each other at the starting points. This is all about your exercise 1.2 and your fundamental theory of arithmetics. We'll discuss about irrational numbers in the next class very detailedly. Exercise 1.3 and also irrational numbers we'll discuss very detailedly. So I suggest all the viewers to like and subscribe the DB Production BGS. Thank you. come here. We are discussing about the real numbers. Real numbers, the third video of the real numbers. In the previous videos, we have discussed about the real numbers, the number systems, the natural numbers, whole numbers, integers, rational numbers, irrational numbers, and the real numbers. But the prime numbers, composite numbers, and also so many theorems, LCM, HCFs, Euclidean division lemma. We have already discussed about them. Now we are going to discuss about the irrational numbers. Detail about the irrational numbers. We have discussed about natural numbers, whole numbers, integers, and rational numbers. Very detailed in class up to class 9. We have discussed about the real numbers. But we are going to discussing about the irrational numbers. Before discussing about the irrational numbers, I suggest all of you that must subscribe, like and subscribe the DB production BGS. Go through the DB production BGS because it is the produce more opportunity to give available classes to all the students. The mathematics classes very easy and very in a different way. So must subscribe, like and subscribe, and keep on your DB production BGS channel. So come to the lessons. First, irrational numbers. Before going to irrational numbers, we have to know what is rational numbers. Rational numbers. In the previous class, we have discussed about that any number which is in the form of P by Q. P by Q, that is Q set Q, that is your rational numbers. Q equals to P by Q. Any numbers can be written as P by Q where P and Q are integers and another factor is Q not equals to 0. The denominator is not equals to 0, that means Q not equals to 0. That means any number which can be used, we can be write in the form of P by Q with respect to P by Q, that is called your rational numbers. Any number we can write in the form of P by Q, that is your rational numbers. But there are some numbers, that means your 2 by 3, 1 by 2, anything, 0.25 and so on, 0.0333, etc. These all are all numbers are your rational numbers. We have discussed about the rational numbers, terminating and non-terminating, repeating. Terminating numbers, this is the terminating numbers, decimal numbers, and this is the non-terminating repeating numbers, repeating decimal numbers. All of the rational numbers. All are the rational numbers. We can find out the rational process. We can write the rational process of all the numbers. 0.25 equals to 25 by 100. 0.03 bar, this can be also we can write in the rational process. Suppose how can we 0.035? Suppose x equals to 0.03 bar. Then 10x equals to 0.3 bar. 100x equals to 3.3 bar. When you eliminate from 100x minus 10x, 100x minus 10x equals to 3.3 bar minus 0.3 bar. This implies this equals to 90x equals to 3 bar would be eliminated. 3 minus 0 equals to 3. This implies x equals to 3 by 90. This is 1 by 30. Anyway, 3 by 90. This is the rational form, P by Q form. So 0.03 bar is equals to 3 by 90. This can be written as the rational process. The repeating, non-terminating, repeating numbers. Non-terminating means when the point will be goes up to infinity. That is non-terminating numbers. non-terminating repeating numbers we can write in the rational process also, in the rational form. Another example, suppose x equals to 0.7 bar. This means 0.777 and so on. So this is repeating non-terminating decimal numbers. We can write the decimal form of this number. Suppose what is 10x equals to 7.7 bar. We have to eliminate 10x minus x. 10x minus x is equals to 7.7 bar minus 0.7 bar. This implies 9x equals to 7. 7 minus 7 bar, 7 bar. We will eliminate 7 minus 0 equals to 7. This equals to x equals to 7 by 9. This is the eliminating process. This is the process where x equals to 0.7 bar. That means 0.7 bar equals to 7 by 9. This equals to 7 by 9. This is the rational process. We can write the rational. Process. The repeating non-terminating decimal numbers. This is the rational form. We can write the rational form. Any other number. Suppose 5.12 bar is bar is equal to 1 2. That means x equals to 5.12121210. 10x equals to 100x. 512.121212. This implies 100x equals to 512.12. Again, 1 2 bar can be eliminated. So 100x minus x equals to 512.12 bar minus 5.12 bar. This implies 99x equals to 512 minus 5, 507. 1 2 bar will be eliminated. So x equals to 507 by 99. This is the rational number. This is the rational number of the repeating non-terminating numbers. So this is the rational numbers. The rational form. This is the rational forms. So this is the we can write. We can convert. We can convert all the repeating non-terminating decimal numbers into their rational forms. In this process, we can find the rational forms. They all are rational numbers. But when the number is decimal number is non-repeating, so what happens to them? Suppose non-repeating, any number. Suppose 0.01, 0.01, 0.0001, and so on. This is non-repeating numbers. Non-terminating and non-repeating numbers. Non-terminating, you cannot terminate it, and non-repeating, any numbers after the decimal, it is non-terminating or non-repeating. Any number is not repeated. So when it is not repeated, it is irrational numbers. It is not considered as the rational numbers. We cannot find the rational form of these numbers. We cannot find the rational form. So that is irrational numbers. So likewise, other number systems, your natural numbers, whole numbers, your integers, and other numbers, integers, rational numbers, irrational numbers are also unlimited or uncountable. That is called irrational number. Irrational numbers. Irrational numbers. What is irrational numbers? The numbers which cannot be formed in the p-value form. The number which cannot be written as the p-value form, that is called irrational numbers. That means any irrational numbers, we cannot write them as p-value, in the form of p-value. That is called irrational numbers. any number which cannot be converted as p by q, that is called your irrational numbers. There are so many irrational numbers: root 2, root 3, root 5, root 6, root 7, root 8, root 10, root 11, root 12, root 13, root 14, root 15, root 17, and so on. Where we have eliminated root 1, root 4, root 9, root 16, this equals to 1 plus minus 1, this equals to plus minus 2, this is equal to plus minus 3, this is plus minus 4. So these are the rational numbers. These are the rational numbers because we can find the square root of these numbers. We can find the square root of this number, root. We can find the root of this number. So they are rational numbers. When we cannot find the root, particular your natural integers, the root in the form of the integers, then they are called irrational numbers. We can that is not there when we discuss through find out the root over in the process, root over process, that will not be eliminated, that will not be repeated. That should not be repeated. So we cannot find the rational forms, p by q forms. We cannot find the p by q form of these numbers. So they all are irrational numbers. Besides this, there are so many irrational numbers also, pi, e, and these and so many pi, e, these are the irrational numbers. E, what is meant by e? 2 less than e less than 3. That means e comes between 2 and 3. E equals to 1 plus 1 plus 1 plus 1 by 6 plus 1 by 6 plus 1 by 24 plus 1 by 120 plus 20. This is the e. 2 plus something. This is the e. So this is unlimited process, unrepeated decimal numbers. When we convert into decimal numbers, it will be unlimited or uncountable or unrepeated. So this is e. What is pi? What is the pi? Pi equals to c by circumference by diameter. When pi is started from the circumference by diameter, the ratio of circumference and diameter will be pi. The circumference of the circle by diameter of circle. When we go through the circle chapter, that is we can find the pi. So c equals to 2 pi r pi d. This equals to pi d. So pi equals to c by d. Pi equals to c by d. You know, c equals to circumference equals to 2 pi r. So pi equals to c by d. C means circumference of the circle and d equals to diameter of the circle. So the ratio of the circumference and the diameter, that is called pi. So that pi, the value of pi is also pi is irrational numbers. From before Christ 3000 in the Vedas, it is the value of pi will be root 10. It is written as root 10. Root 10. All are the approximate value, not the correct value. The values of the pi, generally you can find pi equals to 22 by 7. We can take generally 22 by 7 in the rational form, but this is not the real value of pi. This is the approximate value. Approximate value of pi. Approximate value of pi. So many scientists in the world, many mathematicians in the world, they describe the different values of the pi. Like we say Vedas. In the Veda, before that is approximately that is written before 3000 before Christ, the value of root 10. In Babylon dynasty, that also before 3000 before Christ, that is 25/8. They are written as 25/8. 5 by 8. The value of pi is 25 by 8. According to Archimedes, that is 22 by 7. According to Archimedes, the value of the pi is equals to 22 by 7. According to Ptolemy, 3.1416, pi equals to 3.1416. This value and this value is generally used. Root also be used in the mensurations. So these are the any forms. Chungchi, Tuchin, the 335 by 133, 335 by 133 according to Chungchi, the value of the pi. According to Aryabhatta, the value of the pi equals to 62,832, 62,000. According to Aryabhatta, the value of the pi equals to 62,832, 62,832 by 20,000. This seems to be eliminated process. It seems to be eliminated process, but that is not the real value. All are the approximate value, nearest value, approximate value of the pi. According to Bhaskaracharya, the value of the pi equals to 3,927 by 250, and the most accurate value of the pi, most accurate value in the modern mathematics, in the modern science is according to Ramanujan, that is 9801 by 1103 root 8. According to Ramanujan, the value of the pi equals to 9,801 by 1,103 root 8. This is the pi value of the various value of the pi. So pi is the very interesting irrational numbers. So now also the scientists, the mathematicians are researching time to time, going through the very nearest and dearest values of the pi. So let us discuss. Let any prime number p divides a square, then p divides a. Suppose a square is divisible by p, then p divides a square if theorem is that let p be a prime numbers. P, if p is prime, if p be a prime numbers, and p if p divides a square, then prove that p divides a. When p divides a square, then p divides a. P divides a, we have to prove that. Suppose a equals to any numbers p1, p2, p3 up to pn. Suppose a equals to p1, p2, p3, p2 up to pn. p1 into p2 into p3, that means p1, p2, p3, p4. A equals to, if p divides a square, that means any number p must be divided a square. A square equals to into p2 into p3 to pn into another p1, p2, p3, p4 to. So a square, when p divides a square, when p divides a square, p divided a square exists in any one of these. When P exists in this process, another P also exists in this process. So P exists in P1, P2, P3, P4 up to P. So if P exists in this process, so that divides a square. That must divide a square. So another P also available is here. So here is P, here is P. The P square, A square. So A. So P is A. Here is P also. So P must divide A. When eliminate this P, then another P also divides A. This is A. This will be A. So P must be another P also exists here. So P divides A. Here this will be eliminated. Then this will be A. A equals to P1, P1, P2, P1, P2, P1, P2, P3, P4 to Pn. Here P exists. So P must be divides A. P must divides A. So P divides A. This is proved. In this way, when if P divides A square, then P must divides A. This is the theorem. It will be utilized in the proving the other assumptions. So then theorem 1.4. Prove that root 2 is irrational. Prove that 1.4. Prove that root 2 is irrational. Irrational. How can you prove that root 2 is irrational? Suppose let us take let P be rational. P is a rational numbers. P with the rational. P is the rational numbers. Then what happened? When root 2, P means root 2. Suppose root 2 is rational numbers. Let root 2 be rational numbers. So root 2 must equals to P by Q. You can write when any number is rational numbers according to the definition of the rational numbers. We know that any number which can be formed as the P by Q, or we can be written as P by Q, that is called your rational numbers. So when root 2 is a rational numbers, we can write root 2 equals to P by Q. Then root 2 Q equals to P. When taking square, root 2Q square equals to P square. This implies P square equals to 2P square. Here P and Q are co-prime. Here P and Q are co-prime. Co-prime means only one is the HCF of these two numbers. That means except one there is not any common numbers between P and Q. So they are the co-primes. That means their HCF is P and HCF of P and Q is 1. So they are co-primes. This is the definition of your rational numbers according to rational numbers, and Q not equals to 0. Here P and Q are co-prime. Q not equals to 0. They are integers. Integer co-prime numbers. They are integers and Q not equals to 0. Q must be not equals to 0. So P square is 2Q square. Q not equal to 0. That means this will not equals to 0. Must be integers. So 2Q square. 2Q square is even number. Here 2Q square even. Even number means it is divisible by 2, and if 2Q square is even, or P square is even, that means P square is divisible by 2. So P is divisible but P is even. When P square is even, then P is also even. when p square is divisible by 2, then p is also divisible by 2. We have discussed about in this sections. P is even, ये first. Then if p is even, that means p equals to 2m. Any even numbers, we can write any even numbers as the form of 2m. So p square equals to 4m square. Here which is first, second, third. First and third. First and third implies first p square equals to 2p square, and in third p square equals to 4m square. So 2q square equals to 4m square. 2q square equals to 4m square. Then q square equals to 4m square by 2, this equals to 2m square. Here 2m square is even. Even why it is even? It is the multiplication of 2m. 2m is the form of 2m. So that is even. When 2m square is even, q square even. Q square is even. Then q is even. So here this is the IV. According to second and IV. According to 7, when the assumption second we get the p is even. Here q is even. For second and IV implies p and q are even. That means their common factor is 2. When two numbers are even, any two numbers are even, then common factor is 2. So p and q are have common factors common factors 2, but we know that p and q are co-prime. But p and q are co-prime. That contradicts the statement. So during the contradicting process, root 2 is irrational. Root 2 is irrational numbers. Root 2 is not rational numbers. If root 2 would be rational numbers, then this contradiction must not occur. If these contradictions occurs, then our assumption that let root 2 be irrational, that is wrong. So root 2 is an irrational numbers. In this way, we can find out, we can prove that the root 2 is irrational numbers. Root 2 is irrational numbers. In this way, you can prove root 3 is irrational numbers. How can find the root 3 irrational numbers? In this way, even. You do not add even. Let us discuss, prove that root 3 is irrational. Same process. This is the same process. How can you find out root 3 is irrational? Suppose let root 3 is rational. Rational. So root 3 equals to p by q, where p and q are co-prime and q not equals to 0. This is the assumptions we take on. This is the definition says of the definition proofs of the rational numbers. According to rational numbers definitions, root 3 equals to p by q, where p and q are co-primes integers. Co-prime integers, they are integers, co-prime integers, and q not equals to 0. So this implies what happened? P equals to root 3q. This implies p square equals to root 3q square. This implies p square equals to 3q square. Where 3q square, 3 divides 3q square. Here 3 divides 3q square. So 3 divides p square. 3q square equals to p square. 3 divides p square. 3 divides p also. That means p has the factors 3. P has a factor 3. It has a factor. When 3 divides p, this is the first, this is the second. Thirdly, when 3 divides p, p equals to 3m. When p divides 3 divides p, that means p equals to 3m must be. That means 3 is a factor of p, must be. So this implies p square pm square. This implies p square equals to 9m square. First and third implies first p square equals to 3q square. P square equals to 9m square. So 3q square equals to 9m square. This implies q square equals to 9m square by 3. This equals to 3m square. So 3m square, 3 divides 3m square. So 3 divides q square, then 3 divides q. According to IV, second and IV. Second 3 divides p, third IV. According to second and IV implies, according to second and IV, 3 divides p and 3 divides q. That means 3 is the common factor of p and q. But we take on that p and q are co-prime numbers. But p and q are co-prime. Co-primes, that means only one is there, common factors, and there is no any other factors, common factors. So this is contradiction. Contradictory. This is contradictory. So root 3 is an irrational number. So root 3 is an irrational numbers. In this way, you can find root 5 also irrational numbers. In this way, you can find root 7 also irrational numbers. In this way, you can prove any numbers, any irrational numbers, that is irrational numbers, we can prove them. We can prove. So this is the process. We can prove the root 3 is irrational numbers, root 2 is irrational numbers. This is the very simplest process. We can, all of you understand very well, very easily. So next we proceed. Then some examples we have to go through some examples, and exercise 1.3. So that 5 minus root 3 rational. So example 10. So that 5 minus root 3 is irrational. Let 5 minus root 3 is irrational. So we take that irrational. Let 5 minus root 3 is rational. That means 5 minus root 3 this is equal to p by q, in the form of p by q. This implies root 3 5 minus p by q equals to root 3. 5 minus p by q root 3. Here we can write p q are co-prime integers and q not equals to 0. This is most important. According to rational number definition of the rational numbers, P by Q, where P, Q are co-prime integers and Q not equals to 0, co-prime integers. Q not equals to 0, that means P by Q is integers, that means rational numbers. I which are rational numbers, this is natural numbers, this is rational numbers. When P by Q is rational, I minus P by Q is rational. According to the rational number, the law we know that the sum and sum, multiplication, subtractions and division of two rational numbers are rational numbers. So I minus P by Q rational. This implies root 3 is rational. But actually root 3 irrational or irrational. Root 3 irrational. So this is contract. So, contractility process. So 5 minus root 3 is irrational. In this way, you can find any numbers which is rational or irrational numbers. You can prove it very easily. Very easy process. Rational number, irrational numbers, we can prove it very easily. Then we go through next example 11. So that 3 root 2 is irrational. Same process. So that 3 root 2 is irrational numbers. Let we take in the contractility process, that means let 3 root 2 is rational. Then 3 root 2 equals to P by Q, where P Q are co-prime integers, where Q not equals to 0. This is the very clear assumptions. This implies root 2 equals to P by 3Q, where P and Q are integers and 3 also are natural numbers. Here P and Q are integers, the 3 is natural, hence P by 3Q is rational. So root 2 is rational. This number is rational, that means root 2 is rational. But we have proved that root 2 is also irrational number. So we have proved again that root 2 is irrational numbers. So this is contradictory. So 3 root 2, hence this implies 3 root 2 is irrational. In this way, you can prove the numbers which are irrational, rationals. Exercise 1.3, prove that root 5 is irrational. Very easy question. When we have proved that root 2 is irrational number, root 3 is irrational numbers. In this way, we can prove that root 5 is irrational number, root 7 is irrational numbers. In same way, in same process, same way, but only the number is changed. So this is task. You can do it very easy. Number 2, prove that 3 plus 2 root 5 is irrational. This is also very easy numbers, very easy process. It's same things, same process. In the same process, you can do it. That is your task also yourself. Very easily you can do it. And other is your number 3, prove that the following are irrationals. 1 by root 2. 1 by root 2 is irrational. Suppose number 3, proof 1 by root 2 is irrational. Let 1 by root 2 is irrational. This implies 1 by root 2 equals to P by Q, where P and Q are integers, Q not equals to 0. They are integers, co-prime integers, Q not equals to 0. This implies root 2 equals to Q by P. 1 by root 2 equals to P by Q, root 2 by 1 by root 2 equals to Q by P. This implies here Q by P, here P by Q is rational, or Q not equals to 0, Q not equals to 0, so Q by P also rational. P by Q totally not 0, Q not equals to 0, P also not equals to 0. Why? 1 by root 2 equals to P by Q. This is not equals to 0. That means P also not equals to 0. This value is 1 by root 2. Any value, then the numerator should not be 0. So Q by P is also rational, where P not equals to 0. This is rational. That means root 2 is rational. When root 2 is rational number, but root 2 is irrational, this is contradictory. This is contradictory. So 1 by root 2 is irrational. This is the irrational numbers. How can you find the rational numbers? What number should be multiplied? What number should be added to these numbers to get the your rational numbers? There should be different things according to your courses. Up to exercise 1.3 we have discussed. In the next class, the revising rational numbers and their decimal expansions. We will discuss in the next class. Up to this class, we have cleared all the things of all the factors. So we remain in the DB protection videos. Like, subscribe. Thank you.